Hi, I'm Maritza, and we are in the red from Irma Rangel's Young Women Leadership School in Dallas, Texas. Today, we will present to you our test box, the smarter way to test today. Our team members consist of Caitlin Moss, the project coordinator, Leslie Macias, the creative design lead, Sofia Nunez, the marketing/research manager, and me, Maritza Maldonado Chavez, the project manager. Working with my teammates was very fun, and I also learned a lot about them and about our research topic. We paid close attention to each other's weaknesses and strengths to choose our team roles. I chose to be the project manager because since it's my first year here at Irma Rangel, I wanted to try to do something different and outside of my comfort zone. And I also wanted to challenge myself. Talents each of us brought to the table are Leslie's creativeness, Caitlin and Sophia's coding skills, and my strong ability to coordinate.
Hello everyone, my name is Caitlin Moss and I'm the project coordinator for In the Red. We decided that I would do best as project coordinator because of my strong leadership skills and how well I can keep everyone on task.
Hi, my name is Sofia Nunez and I'm the researcher/marketing manager of the team. We decided this was the best role for me because of my great researching skills.
Hello, my name is Leslie Macias, and based on my skills and familiarity with the arts field, I decided to take the creative design lead role during this project.
The main overall purpose of the text box is to make a more convenient and readily accessible way to test COVID. Worldwide, we are still lacking in test locations, both in number and accessibility. Through our Testbox kiosk, we'll provide a greater number of readily accessible testing locations. Testbox can be set up almost anywhere, outside of pharmacies, grocery stores, etc., etc. Considering the Testbox can go anywhere, people won't have to travel hours away just to get tested. It will be down the street or right around the corner. The method that we decided to use for this project is the engineering method. We use this method to make the prototype of the text box and program the color sensor in Raspberry Pi.
From my previous research, I've discovered that a few programs like UNICEF and the Bill and Melinda Gates Foundation have reserved 700 million vaccines. That's just enough for 67 of the most low-income countries to have 10% of their population vaccinated. Because of this, it is important that these communities have better access to COVID vaccines and tests. Poor countries are the ones most affected by this since they have no good economy or money to afford testing or just necessities that are useful to not contract the virus or spread it. As you can see in the graph, while testing is lacking worldwide in terms of the size of the pandemic, the countries with the lowest GDP receive the least amount of tests. Our solution is to design a Testbox kiosk for easily accessible testing and results and poor countries and people with less advantages to have access to COVID-19 tests.
Here is a prototype for the test box, and if you haven't noticed already, yes, we use the Redbox as inspiration. At the top, we have some sprinklers that will spray disinfectant after each use to sanitize. In the center, we have a screen which is where people will fill out their information through Google Forms so that they can get the results back via phone number or email. A video will later show how this is done. Once they have filled their information and selected their test type, a video will pop up giving instructions as to how to take and return the test. An expert at UT Southwestern recommended having different slots for each PCR and rapid test. The PCR would take around 4 to 5 days to get results back, and the rapid test 15 minutes. People would take the test from the very bottom of whichever test they chose, take the test, and for sanitary reasons, put it in a plastic bag and then return it through the circles located above. Later, personnel from the lab will come and pick up the PCR test up, take them back to the lab for testing. On the other hand, the rapid test will be tested by the test box using a color sensor located inside it. The materials used were two Raspberry Pi 3s that were donated, as well as a color sensor TCS 3200, a CQ robot color sensor, and a Freno Super Starter Kit that we purchased. Lastly, Google Forms and Cleckly app for designing the prototype.
For our experiments executed, we used the engineering method and we brainstormed and decided that the best way to read the results would be with a color sensor. The color sensor would be placed inside of the test box and would read the results. We set up the Raspberry Pi, which is like a small computer, connected it with a sensor, and we researched different ways to set up wires and different codes that we can run on it to make it work. During our research, we discovered that COVID-19 tests read the color red if it was a positive test and the color blue if it was a negative test. The first day, we tried multiple tests and codes, and we got an error message every time. We would read the error message and try to fix the problem, but we didn't get any luck. Then we consulted many great programming experts who actually work with programming games. They helped us wire, troubleshoot, and again, try different codes, but still did not work. A little bit about Raspberry Pis is that they're very big in the UK, and there's a foundation that even donates them to schools. And we even spoke to a programmer in the UK, and we still couldn't figure it out. And the next solution was to try a different sensor and a different Raspberry Pi. Both of these were donated by the computer programmers that were helping us. The sensor began to smoke and the test failed. We're still troubleshooting, and hopefully by the day of the competition, we'll be able to properly show how it all works. Here's a video of what a working color sensor does. Here it shows them putting up multiple colors up to the color sensor, and in the little black screen to the left, it is showing the code transferring into it and detecting the color they put up. What we want the code to say is that the word positive or negative for the test results.
This form is what pops up whenever a patient first approaches the test box. And this is where they will put all the information so the results can come back to them. At the top of the form, there is a link that they could click on to get their results back. Once they click on that link, they will be redirected to another site to enter their phone number and their results will appear. As you can see here, our patient is entering their phone number to get back their results. Once they enter their phone number, their results will come back either negative or positive.
In conclusion, there are places around the world who still have limited access to COVID-19 testing. The Testbox is a free, easily accessible solution that can be placed anywhere. With the correct coding and color sensor, our Testbox will be able to deliver results by simply typing in your phone number. A Raspberry Pi is an affordable and small computer system that will easily work inside a Testbox. Multiple sensors can be connected to the Raspberry Pi. And remember, people would have to go out their way to get a test. Instead, it will be located to them as close as possible. Thank you for attending our presentation, and thank you for taking the time.